All right, moving on to example 4. We have a problem that's asking us to find a unit vector. Right here is the formula for the unit vector. A unit vector is nothing more than taking a vector and dividing it by its magnitude. And if you remember, magnitude is just the length of a vector. So we're just going to apply a little distance formula basically to find the magnitude. Okay, and we're going to divide it into the actual coordinates for the vector. That's all unit vector is. Now, if you read example 4, it says we got a vector 5i minus 7j. And then we're supposed to find the unit vector. Well, what in the world is this I and j stuff? Okay, this is a new concept for you. Once you figure it out, it's not a hard concept by any means. If you just skim your eyes over a little bit on your paper, the standard unit vectors are what I and j are. So I stands for nothing more than 1, 0. J stands for nothing more than 0, 1. So I is a vector 1, 0, so it would just be literally straight over 1 unit on the x-axis. There is my vector I. My vector j is simply straight up 1 unit. There is my vector j. I mean, that's all these vectors are. Now the reason, just to give you a little background, the reason this ij stuff exists is because back in the day, when your parents were doing math, there were not, Microsoft equation editors and stuff like that. So to write textbooks and to communicate in math, they just used I and j instead of writing, the component form of a vector symbol. We didn't have insert symbols, so they just had to use I and j. So once we interpret this, you'll see how it works, and it's actually quite simple. Let's just go through the motions one time. All we want to do is interpret this I and j stuff. So I'm going to go ahead and take my vector, my quantity of 5, and I'm going to write it 5i is nothing more than 5 outside of the vector 1, 0. That's all 5i means. Okay? And if I distribute my 5, I just get 5, 0. Okay, no big deal at all. So that's all it means to have 5i. It just means 5 times the vector 1, 0. That's just 5, 0. And I'm going to do the same with this negative 7. I'm going to treat this like it says plus negative 7. Okay, so I'm going to take my negative 7j, and I'm going to go ahead and take my negative 7, write it outside what j is, which is 0, 1. And I'm going to go ahead and distribute my negative 7 to there, and I get, 0, negative 7. And then I'm just supposed to put these two vectors together. So I'm going to put these two vectors together. So 5i minus 7j, or plus negative 7j, if you will, would just give me 5, comma, negative 7 in component form. So when you see, once you kind of look at this overall picture, you're like, well, okay, duh. If you see 5i plus negative 7j, just immediately rewrite it as I is the x-coordinate, j is the y-coordinate. Whatever's in front of I is your x-coordinate. Whatever is in front of j is your y-coordinate. And it's because of this math right here. You could redo that math every time if you really want to, but I mean, I is just the x-coordinate, j is just the y-coordinate. That's all you have to really interpret. Okay, so now that we've interpreted that, let's go ahead and take care of finding the unit vector. Okay, so all of that was just interpreting 5i plus 7j, or I'm sorry, minus 7j. You'll never have to do this math again. Just interpret it right into I is the x-coordinate, j is the y-coordinate. So now that we've interpreted that, let's do our unit vector. So here's the math for the unit vector. The unit vector is simply take the vector, so our vector is 5, negative 7, and we're going to divide it by its magnitude. Now remember, magnitude is just the length of the vector. So I'm just taking these coordinates right here and I'm plugging them into the Pythagorean theorem to get its magnitude. When it's in component form, you can just plug it right into the Pythagorean theorem. So it's 5 squared plus negative 7 squared. And when I work out 5 squared plus negative 7 squared, hit some numbers here, I get 8.602. So I'm going to go ahead and rewrite it as 5 negative 7 divided by, I just worked out the magnitude, and it came out 8.602. And I'm going to go ahead and distribute that to each of those terms. Just like we distributed our multiplication, we can distribute our division. So I'm going to take 5 divided by that number. So my new, my new x coordinate is 0.581. And then I'm going to go ahead and take that 8.602, take it into the negative 7. And I get negative 0.13, or I'm sorry, rounds to 0.14. Okay, so there is my new unit vector. Now you're probably asking yourself, excuse me, I gotta move the camera over a little bit. You're probably asking yourself, okay, what in the world is a unit vector? Well, a unit vector is just simply taking our vector 5, negative 7, and we scrunched it down to be the same vector direction-wise, but we scrunched it down to a magnitude of 1. Basically, we'd want to do that so it fits on the unit circle. Now this one has a unique application. I really like it. This problem right here actually has us apply this right away. It says, then create a vector that has a force of 200 pounds acting in the same direction. Well, we already have a vector acting in the same direction, and this vector is 1 unit long. Okay, so if we drew it real quick, just to give you an idea, 5, negative 7 would be about, right in here somewhere, correct? Okay, well, 0.581 and negative 0.1814 would be right about here. It would be in that exact same direction as the original vector. It's just shrunk down to 1 unit long. So that's all we've done, is taken the original vector that was this long and we shrunk it down to 1 unit long. And now they're asking us create a vector that has a force of 200 pounds. Well, if this vector right here has a force of 1, all we have to do is take that vector and multiply it by 200. So that's all we're going to do. To create a new vector that has a force of 200, we're just going to multiply this vector by 200. So here's my new vector that has a force of 200. I'm just going to take 200 and multiply it by my unit vector, 0.581, comma, negative 0.814. And I'm just going to distribute 200 to that, and I'll have my new vector. So I'm going to take 0.581 times 200, and I get 116. I'm just rounding the nearest tenth here, just trying to be fast. On the AP Calc exam, carry 3 decimals. And I'm going to take my 0.814, negative 0.814, multiply that by 200, and I get negative 162.8. Obviously, I'm not going to try to draw that on this scale because it would be way over, way down, but it would be on that same line. It would just have a length of 200 to it. It would be 116.2 over, it would be 162.8 down, and it would be right on this same line. It would just be a length of 200. So there's example 4. We'll move on to example 5.